Hello and welcome to StressOff. This is the place where we conduct finite element analysis using several different softwares that are available in the market. Some of them are open source softwares like FreeCAD, Calculix, and Salome Mecca. Some of them are softwares that are to be paid for, like Autodesk Inventor, Ansys. Some of the softwares like Prepo Max are closed source, but they use Calculix as their finite element analysis engine. All of these softwares will be using to conduct a finite element analysis of a cube. The length of the cube is 1 meter, width of the cube is 1 meter, and the height of the cube is 1 meter. So it's 1 cubic meter cube. The pressure to be applied on the top face is 1 megapascals, and the bottom face will be constrained. There are a few different constraints that we'll be trying out in this software StressOff, so stay tuned. In this video of StressOff, we are going to see how to conduct a finite element analysis of 1 cubic meter steel cube using Ansys. Let's go in and first select or save this project, because whenever you start Ansys, it'll open up with an unsaved project, so it opens up a new project. So let's save this project first, and we'll say Ansys case 1, case 1. After the project has been saved, let's go in and have a look at static structural analysis, and we'll add that into the project schema. In here, let's first go in and have a look at the engineering data. What I'm mostly interested in is to convert or to see if the values given here are exactly what I want. So what we have been using is 210000 megapascals as the Young's modulus, and Poisson's ratio is 0.3. So when that is done, you can go in and save this and close the engineering data. After that, let's right click on geometry and say use new space claim geometry. So let's create a geometry. And for our case, it is a simple geometry where we just have to create a cube with length, width, and height of 1 meter. So let's go in and let's wait. After space claim loads, we can go in and select a rectangle. Select the center point and start drawing. Now let's enter 1000 for length. Press tab and 1000 for width. Once when that is done, let's just click on end sketch editing. After that, let's pull this by 1000 millimeters. So once when this is done, let's just click on select and just quickly rotate the cube and see if it is, well, it is 1 cubic meter. So let's just close space claim. Once when you close space claim, you will be back to our workbench where we can go in and select our model. Let's just go in and double click model. Once the model has loaded fully, we can see that there is one geometry with one solid. Material is structural steel, what we entered in. Coordinate system, we are not much worried about. Let's go in mesh. Now here, let's quickly have a look at if we can figure out how to get a 100 millimeter mesh. Not 100 meters, 800 millimeters. Okay, 0.1. Let's go in and right click mesh and we'll say generate mesh. Once when the mesh has been generated, one thing to note here is that in Ansys by default you can get a hexahedral mesh. Now let's just calculate or count the number of boxes and see what we said is correct or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So this is not the case. What we want is not the default size as 0.1 but the element size as 0.1. Let's go in, right click and update mesh. After the mesh has updated, let's go in and check 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So there are 10 elements per edge and that's what we want. After that, let's go in and select analysis settings. So we will need to insert pressure. We will go in and select the top face, click on apply for geometry, and for pressure we'll just say 1000 pascals is just kilopascal. So let's just go in and add 1 megapascal load. After that load has been added, let's rotate. Let's go back to insert and we will say either we can say fixed support or we can just go in and add displacement. So let's just go in and add displacement to the bottom and say we just want y to be 0. Let's see if Ansys allows us to continue with this analysis. Let's click on solve and Ansys complains that not enough constraints are there. So let's go in and add some constraints. But we'll wait for the analysis to finish. We can go in and pause the analysis. Yep, so again, it's just giving us the answer that not enough constraints are there. If we do go in and say we would like to see total deformation and we would like to see directional deformation in y-axis. Also, we would like to see stresses in 1 misses. Now, if we go in and say evaluate all results, the total deformation, we are not much worried or concerned about that. We are concerned about the directional deformation. Here we can see that the units are in meters. So if we convert it into millimeters, this is 4.7619 micrometers. Now again, one thing to keep in mind is that Ansys did allow us to conduct the finite element analysis even though there were less number of constraints. Let's quickly check the equivalent stresses. Here equivalent stresses are 1 to the power 6 pascals, or in other words 1 megapascal, which is consistent. Now let's go in and insert another displacement type constraint, and in this scenario let's just go in and select the edge and let's give it a displacement of 0. Add another one and let's give it a displacement of Z0. After this is done, let's right click on solve, and then again let's go in, and we are not much worried about the displacement or deformation in all 3 directions, but predominantly in y direction. Here again we can see that the maximum displacement or deformation on the top face is 4.7619 micrometers. Again, let's check the equivalent stresses, which are again 1 megapascal throughout or the entire cube. Now let's go in and delete these displacements. We can go in and suppress them as well. Let's just go in and quickly suppress them. Let's go in and insert a fixed support for the entire bottom face. When that is done, let's quickly say solve. Let's go in and have a look at not the total deformation. Well, we can have a look at total deformation here as well. So the total deformation is 4.7721 micrometers, or if we just check Y deflection, it is 4.6576 micrometers. Equivalent stresses are, for most of the part, it is somewhere in this range. So the green one reflects somewhere around 1 megapascal. In around here, this section, it is around say 0.8 megapascals. In the center of the cube, it is mostly 0.5 megapascals, whereas on the corners we get a peak stress of 1.88 megapascals, which is again consistent with all the other softwares that we have used. So we have seen how to conduct a finite element analysis of a cubic meter, which is made up of steel, using Ansys and using 3 different types of boundary conditions. First one was the bottom face is just supported in Y. So the displacement for the bottom face on Y direction is set to 0. And initially I thought it won't let us, but then the analysis did continue. So that is again in line with what we saw with FreeCAD, and also what we saw with the other software, PrepoMax and also Calculix. Now the other one in which we restrain the 2 edges, one in X direction and the other in Z direction, and the third one in which we restrain the bottom face in all X, Y and Z direction, and we got the results. If you like this video, stay with us, keep on checking the other videos in this video series, and we'll see you soon. Thank you.